Welcome back to Area Diesel Service. Today we're going to do a collaboration video with fellow YouTube content creator Red Poppy Ranch. Red Poppy Ranch is an off-grid lifestyle type of channel. If you're not familiar, go check out his channel. He's got a tremendous amount of excellent content over there. Think historically Heath has been known as a plumber, but if you watch his channel, you'll see that he's pretty well capable of everything. Construction, electrician, earthwork, excavation, ranching, all of the above. And he's built his entire homestead with his own hands. Quite a transformation. So we've been talking with Heath. He has a first-gen Dodge pickup, a 91 Dodge four-wheel drive, standard cab, 5.9 liter Cummins. This is the VE style rotary injection pump. Heath is also pretty handy in the repair shop. If you follow his channel, you'll know that he's constantly upgrading and fixing his own vehicle. Okay, so 91 Dodge first gen is factory rated at 160 horsepower. That's not enough for what Heath is doing. Pulling trailers, pushing snow, he works his rigs, and he's gonna need a little bit more power out of his truck. That's where Area Diesel Service comes into the picture. What can we do on a first gen to get some safe, reliable, working class performance improvements, and also try to do it in a cost-effective manner, because a 30-year-old truck won't command a bunch of exotic high-performance parts. What can we do in a realistic scenario to help Heath out? This is the factory turbo off of Heath's truck. This is not Heath's, this is out of our inventory, but this is what his truck calls for. This is an H1C model turbocharger manufactured by Holset or Cummins Turbo Technologies. This turbo in stock configuration has a 54 millimeter compressor wheel inducer, and it has a 21 centimeter turbine housing. 21 centimeter is a way that engineers express the sizing of the turbine housing and the speed at which the exhaust gas passes through this turbine housing. For the turbocharger part of this modification, what we're going to do is we're going to harvest these two cores from our hoard of core inventory, and we're going to utilize the compressor side of this turbocharger and the exhaust side of this turbocharger, effectively making a hybrid or a custom or a bench-made turbo specifically for Heath's application, and also to facilitate the fueling modifications that we're going to talk about later. Stock turbo, 54 millimeter. We're going to harvest the compressor side out of this core, and we're going to upgrade to a 58 millimeter. 4 millimeter increase in the compressor wheel inducer, and we're going to harvest the exhaust side out of this core. Factory unit called for a 21 centimeter turbine housing. We're going to consume this turbine housing, which is a 16 centimeter turbine housing. Same dimensions on the turbine wheel, but we're effectively going to tighten up this exhaust housing so that the exhaust gas coming out of the engine has to pass through it quicker. So we're going to spool the turbo sooner, and we're going to drive the turbo harder. With that in conjunction with the larger compressor wheel, we're going to move a higher volume of air, and we're going to move it sooner in the RPM band. Okay, we're going to take these cores back to the turbo shop, and we're going to follow them through the process of being remanufactured. We'll get them back there, we'll tear these units down, clean them up, run the subcomponents through the machine shop, take them back up to the build-up area. We'll show you assembling this turbo, and then we'll meet you back up here at the parts counter. The folks in the turbo shop and machine shop are a little camera shy. They have expressed to us that they don't want to be on video, and we might have a hard time getting them to talk us through what they're doing. So I'll do my best to narrate as we follow through the process here. If I skip over anything, don't hesitate to drop a question in the comment section, and we'll follow up with an answer there. Alright, we're back in the teardown shop now, and we're going to disassemble this turbo so we can harvest the components that we're looking for. So hopefully the audio is coming through okay. These guys are working back here as we're doing this. You can see there he's got the compressor V-band off. I'll pop the compressor housing off. Get a little sticky sometimes. We got dissimilar metals here. Alright, compressor cover off. Again, this turbo, we're after the turbine housing, and we're after the turbine wheel. Gonna hold the turbine wheel. Take the compressor wheel nut off. Going to drive the turbine wheel out of the compressor wheel.
We'll go a different route here. Take this out.
Okay, now we're going to separate the turbine housing from the bearing housing. This will reveal what we refer to as a cartridge. So, center housing, rotating assembly. It's the shaft and wheel, compressor wheel, bearing housing, and internal components. Compressor wheel come off, bearing housing, turbine wheel, heat shield, okay, now this is the H1C style turbocharger. And you'll see when we get into this, bearing housing and backplate are two different components. When they went to the HX35 style turbo, this became one complete casting, so it was not a two-part design. And that was really about the only difference between an H1C and an HX35. Alright, so we've got this turbo torn apart now. This is the H1C style turbo that we're going to harvest the turbine wheel and turbine housing out of. Jeff got it torn down for us, and we're going to take a look at these components. So this is the turbine wheel out of this core, and upon initial inspection we can tell that it's going to need a little work. Bearing journals are a little scored. Seal area looks reasonably okay, and the head of the wheel itself appears to be fine. So we're going to clean this up and show you the process for remanufacturing the turbine wheel, and then the turbine housing. We'll show you what we do with it. We're going to bake it to get rid of the soot and crud and grease and grime, and then we'll blast it to get it cleaned up so we can do an inspection on a clean component, make sure that it's going to be good to go again. We're not going to watch the process of tearing down the other turbo. Very similar. The other turbo is where we're going to harvest the compressor cover and the compressor wheel. Similar process there. We'll bake them, get them cleaned up, blast them so we can see what we're working with, and then we'll feed them back to the production department where they're going to reassemble this and come up with a finished good. So we'll move along to the next step. Alright, so this is the Peterson bake ovens. We use this after initial teardown to get the carbon, grease, and grime off of these components. 600 degrees for 6 hours, and we're going to remove and loosen up all of the carbon and grease from these components. These are sample components after the baking process. So you can see there's no more wet or loose grime or carbon, they are still pretty unattractive. Here's an aluminum compressor cover. Step one, cleaning process, get them baked. All right, this is the blast cabinet we use for cast iron back here. So you're gonna see we've come out of the bake oven. We're still fairly gnarly. We're gonna throw it in this blaster, clean it up, and we'll show you how it comes out. All right, so here's an example of what comes out of the blasters. Cleaned up and ready to go. All right, now we're back in the machine shop and we're going to show you the process on the turbine wheel. So this has come out of teardown, it's been cleaned up and blasted. Now we're going to polish the journal bearing area, we're going to polish the seal area so we can get good measurement and good inspection to make sure we can reuse this turbine wheel. So we're going to show you over here step one. We're going to chuck this wheel up in a drill press. We're going to hit it with some 320, then we're going to hit it with some 600, then we're going to pull it out and do an inspection. Thoroughly cleaned and polished, we've measured this shaft and we found that it has about 1/1000th and a half wear in it. So if we put this back in a turbo, it's got too much play, it's not going to live. We're going to take this over to the grinder and we're going to grind it undersized, and then we'll use an undersized bearing and restore this back to factory fit. All right, now we've got the shaft in the ITEL precision press. So before we go to grinding on this shaft, we need to make sure that it's straight and true. Effectively, this is a hydraulic press, but an extremely precision instrument. You can see we've got the wheel chucked up in the fixture. We've got 3 indicators on here where we're measuring straightness. We get it fixtured in here and we rotate the wheel. These dial indicators are measuring in tenths, 4 decimal places, fraction of an inch. We're checking for straightness and trying to identify if it's bent, where it's bent. If it's good to go from here, we'll go straight to the grinder. If not, we'll run the ram down on the bend, straighten it back out. They have memory, so you've got to let them rest a little bit. So you find the high spot, try and knock it down, let it rest, take another measurement, run it again. We'll watch this shaft get straight.
When I go into doing this, I take and mark it where it's high at. And I do the same down here. And you got these little things right here you set up.
End. We're pretty close, so we don't have to.
All right, we're back at the cylindrical shaft grinder now. So remember when we measured the shaft earlier, we found that we were about 1/1000th and a half undersized. The bearings for remanufacturing these come in nominal sizes, usually increments of 5 thousandths. We need to take it to the next nominal measurement so we can rebuild this turbo. We've got it straight, we've got it chucked up in the grinder. We're going to take about 3.5 thousandths off of the journal bearing area. We'll measure it and inspect it again, and then we'll go up for assembly. All right, so he's going to come in and touch off on this shaft. We're going to make a pass across it, get a baseline, then we'll measure, figure out how much more we need to take off, We usually take bites of about 1/1000th of an inch. We'll make a run and we'll take a look at it. Hand feeding across the journal so we can get right up to the back of the seal area. So we took it off and measured it. We measured it on both ends to make sure that we're perfectly parallel, and we are. We found that we're just under 1/1000th short of getting to where we need to be. We're going to take another pass and then we'll measure it again. Shaft is now ground undersized. Factory specification is 432 thousandths. We went 5 thousandths to clean this shaft up, so we're at 427 thousandths. Tolerance, couple of tenths, so pretty tight machining on this stuff. This is now ready to go over to balancing, and we'll follow it over to that process. All right, now we're over at the balancing machines. This is a process that I'm probably going to butcher because I don't know anything about it, but obviously at 100,000 RPMs, a properly balanced component is an important part of a successful rebuild. This is kind of step one balancing. We also have a VSR or a high-speed core balancer once the components are assembled. This is phase one. This balancer has what is basically a strobe light here, and you can see we've added a sticky weight, so we're going to use that to calibrate a heavy spot in the turbine wheel. I'll get out of the way in a minute and we'll watch Rhodesy as he goes through this process, but he's going to spin the machine up and he's going to center the strobe on the heavy spot at top dead center. Okay, then he'll end up taking the weight off, he'll run it again, and that will reveal the true heavy spot on this shaft. And this gauge here will indicate to some degree how far out of balance the shaft is. We'll take the shaft off, we'll take it over to a grinder, we'll remove some material on both planes of the turbine wheel, we'll bring it back, we'll run it again, and we'll see if we can get it into spec. Sometimes you can chase your tail here, sometimes these guys nail it on the first time. They've done a lot of them, so it's kind of an experience and an expertise thing, but I'll get out of the way and we'll watch an expert balance this wheel. So he's using these dials to bring that strobe in to illuminate that weight at top dead center. So he's got her dialed in, shut her down, going to take that weight off of it.
And you want to make sure you get it all off there too, because you don't want to
clean it up. We don't want any of that left on there. Gonna run it up again.
see how far that's out.
And he's got his gauge buried, so he's maxed out on imbalance.
That's that side.
Now he's marking his heavy spot. Make sure he's got it marked right.
Usually they're pretty much right across from each other when they're like that.
Okay, so he's taken his initial weight removal off of the wheel. Before we had this gauge pegged with imbalance. We check it now. He's about 6. We're trying to get her down under 1 or under half. It's back and forth, so he's gonna mark it again over to the grinder, take some more material off, come back over here, run it again until we get it within specification for tolerable imbalance. Once we get it to that point, we'll bring it up to the assembly area and it'll be ready to go back into a turbo. All right, we've got our components and we're in the assembly area. Quick rundown, we didn't hit everything in the entire process, but we're going to talk about it a little bit more right here. Turbine housing, again, cleaned up and inspected, reclaimed, ready to go. Again, this is one of the primary upgrades to Heath's turbo. Again, we've gone from a 21 centimeter squared to a 16. Tightened up the airflow on the turbine housing. Turbine wheel is stock in size. We've gone 5/1000 undersize on the journals. Checked it for straightness. Seal area is good. And we've balanced this back to within specification. Bearing housing. Again, we're going to the HX35 style bearing housing. Now you can see the back plate is cast into the rest of the bearing housing. We're going to attach the compressor cover with the snap ring. We didn't follow the process here, but the journal through the bearing housing is critical. This particular housing ended up 5/1000 oversize on the journal, and we also went oversize on the seal area. When we go to put this together, we're going to have some unique components. We've got a 5.5 journal bearing, 5/1000 smaller on the ID to make up for the material we removed from the shaft, 5/1000 larger on the OD to make up for the material we removed from the bearing housing, restoring factory tolerance. Also oversized on the seal area. The turbine wheel seal is also unique, not a stock seal. Compressor wheel, we didn't follow the process here. Again, we've baked, blasted, balanced, and cleaned up. You can see fresh balancing marks here where we ran it through the process. These are factory balancing marks. You can see on the back we took a little bit off here to balance the compressor wheel. Compressor cover harvested from the other core, cleaned and inspected, ready to go. So we've got it staged out. We've got the rest of the components for assembly. We've got fresh bearings and seals. We're going to put it back together.
Well, hello, my name's Eli, and I am the turbo buildup guy. First thing we do is we build the cartridge, which is the wheels assembled with the bearing housing, and then we will assemble them into their housings. As said, the parts are special. They're oversized parts, and that's to make up for the machine work. First thing I do is put in the bearing, install some retaining rings, and those will hold the bearings in place. Just making sure it's all seated. There's a groove in there they sit into. I oil everything. And here maybe you can see where the bearing is now being held. So that's, I call it the top bearing, not really the top. Then I flip it over and do it again.
Do those snap rings have a particular orientation when they go in?
So I always do one with the opening facing to my right, and then when I put the next one on, I always have it face the left.
And what about the fashion in which that snap ring is stamped? Don't we put the sharp side away from the bearing?
Yeah, so it's probably very hard to see, but there is the way it's stamped, there's a side that's slightly beveled, and then there is more of a flat side. I always put the beveled side towards the bearing, and then as the stamp happens, if there's anything sharp that maybe didn't get taken off during whatever kind of cleanup process it might go through, we know that it's not going to rub the bearing.
It'd be worth noting that the turbine wheel doesn't impact or touch the bearings, nor do the bearings touch the bearing housing during normal operation. So engine oil pressure charges the clearance in the bearing housing between the shaft and the bearing, and between the bearings and the housing, and the shaft and bearings float in a pressurized film of oil. So there is effectively no contact, no wear. It's designed to ride in a film of oil.
Yes, that's why I like to pre-oil as I build, so that way it's kind of there. All right, our journal bearings are in place. All right, next piece is thrust collar. There's a raised area and a flat spot. The raised area points up. It has its own little pocket that it kind of just sits in. Next is the thrust bearing. There is a oil hole here that lines up with the oil hole here, and it allows oil to pass through. I put a little bit through to make sure that it's not clogged.
So journal bearings are controlling radial play, excuse me, radial play. Thrust bearing is controlling axial play. So you'll notice you'll get some up and down or radial play. That's by design. That's the clearance that the oil pressure takes up. The thrust or axial play is set to a really, really tight tolerance. So you'll get effectively no in and out shaft play.
Correct. I went ahead and set my steel ring in there. So next we have the oil slinger and a piston ring. So I'm going to piston ring, pinch groove, and then this style of turbo doesn't have the back plate. As you said, this has already been molded and casted in there, but it gets a seal plate. So slinger goes into the seal plate. I checked that there's a little bit of movement. I can kind of move the slinger a little. To me, that's good. If it was very tight in there, I would think there's something wrong with the back plate. And then here we have an oil baffle or oil deflector. It sets up in there.
We're talking about the compressor side piston ring seal.
Yeah.
The seal is a butt cut piston ring, so it's not a positive style oil seal. It recommends that oil doesn't leak past it, but the true thing that keeps oil inside your turbo is the differential between pressure in the end housing and pressure in the bearing housing. If you get an application issue, your turbo will leak oil, and we'll talk about some of that at the counter when we wrap this up, but just keep in mind they don't have seals as we know them, like on a crankshaft, a rear main seal. They are not a perfect seal.
This is the only rubber seal that exists in most turbos. Alright, so with that in place, put a little oil there, put a little oil on the outside edge. My oil baffle will go towards the drain. Kind of just give it a good push in. And then it has its own retaining ring. And I follow the same thing I do with the retaining rings that are inside. So I had to the right, to the left, and point it back to the right. And I just want to make sure it's good and seated, so I tap. I just give a little tap. All right, almost there. So then we have the heat shield. Then we have our turbine wheel and our piston ring. I have a pair of modified pliers that help me put the piston ring in its groove. It just needs to be opened a little to help slide it down. And then we're in place.
Same thing on the turbine side. It's not a positive seal. It's a butt cut piston ring. And again, it's the differential in pressures that keep the oil inside the turbo.
Just like with those parts, I put oil. A little pop puts it, seats it in place. Turn that up. Pressure wheel. Shaft nut. Most shaft nuts on turbos are left-hand influence. So I like to seat it so that I can pick it up and nothing ships. Bring it over to my vise. And I put it to the torque. At about 130, 135.
135 inch-pounds.
Yes, my bad, yes. And so here we have a completed, what we call a cartridge. Now we can put it into the housings. I always put the cartridge into the compressor housing first. I give it a spin just to make sure that my wheels aren't, the compressor wheel's not hitting the housing. Everything's fine there. The H1 style is held by a V-band. The HX styles are held by a big C-clamp. And I like to give them a tab just to make sure they're seated. Everything still feels good. Alright. At this point we would call it a super core. And it's ready to be turned over into a turbo housing. I tighten bolts, I do every other one. Just so that way I know that it doesn't get clocked or stuck to one angle. Give it a spin. Feels pretty good. Put a plug in the drain. Pre-lube a little. Just giving the wheels a spin, making sure I don't feel any type of contact or any type of catching. Put a plug in there. Visually look to make sure that I have used the right parts. All looks good. Last step here is add a tag.
What's the orientation? So this configuration of parts could fit a number of different applications. The orientation is the relationship of the end housings in comparison to the bearing housing. So
Correct.
the bearing housing drain is kind of the gospel.
So actually, I use the intake as kind of my center.
Okay.
So this orientation would be 180 degrees over 340 degrees. Yes.
So the goal is when this goes on the engine, we want the drain to be as close to 6 o'clock as possible.
Yeah.
It's a gravity drain system. So if the drain is not straight down, if you've got it to the side, it'll pressurize the drain side of the cavity, cause your turbocharger to leak. Orientation is really critical. You want the drain as close to the bottom so the oil can get away from the turbocharger. We're going to set it at the same orientation as the stock turbo from this truck.
180 degrees over 340 degrees.
Okay. And is it set there now?
It's set there now.
Turbo's built. The last step is we need to identify it. We're going to part number this as part number special. This is a custom Benchmade configuration. There is not a factory part number for this assembly. We're going to make a tag to identify what we've done here, and then we'll serialize it so in the future we would know how we built it and from what components. We'll take you over, show you making a data plate, and we'll be done. Last step in turbo buildup is identify the product. We're going to take a nameplate, we're going to put it in the laser engraver, and we're going to make a tag for this turbo so down the road we know what we did, what went into it, how we arrived at it. We'll show you a shot of this thing engraving a data plate. All right. Okay, turbocharger is built and ready to go. So we're back at the parts counter and we're going to kind of walk through the full solution that we've come up for Heath and his first gen Dodge. Turbo we've touched on. We tried to hit the highlights of the rebuild. We obviously didn't capture all of it, but we hit most of the big stuff. 4mm larger compressor wheel to handle a larger volume of air. And we've gone from a 21 to a 16 centimeter turbine housing. We're going to drive the turbo harder, spool it quicker, and move this larger wheel more and faster. This is going to provide the air for the performance upgrades we're doing here. Turbo is complete, gaskets included, oil inlet adapter, should have everything he needs to go back together, should have the exact same outline as the turbo coming off. Might have to play with the orientation again, but should be set pretty close. That's the turbocharger part of this upgrade. In order to fully utilize the turbocharger, we're going to have to make some fueling modifications as well. Fuel system upgrades to utilize this new, bigger turbocharger. First thing, fuel injector. So this is an upgraded injector over the stock unit in Heath's truck. This is a brand new Bosch injector off of the shelf. It's for a different application, but it's going to be considered a pretty good upgrade for what Heath has going on. Factory injectors in his truck is what we call a 4x12 injector. 4 nozzle orifice openings, 12 thousandths in diameter, 155 degree spray angle. This injector out of another stock Cummins application is still 4 holes, still 155 degree spray angle, but now we're 13 thousandths orifices. 12 to 13 thousandths, seemingly small. It is small, but what we're after is total area of orifice opening. You know, 12 to 13 is probably 7% larger diameter, but when we talk about total surface area of the opening, we're going to go up probably 15%. Pretty significant upgrade in the fuel injector department. With the injectors, we're going to send out a set of dust covers. We're actually going to send him an extra because seemingly you always destroy one of those trying to put them on. All of the components for sealing up the return line system on his engine. Another thing to look out for, OEM first design used a 9mm injector nozzle. The diameter of the nozzle was 9mm. That was the first design. The latest current design is 7mm. We don't know what injector style is in Heath's engine, so we're going to send this style nozzle spacer. If he pulls 9s out and puts 7s in, he's going to have an issue. If he does have 9s, goes to install these injectors, he'll use these spacers, shims, to make up the difference, so you can put a 7mm injector in a 9mm head. Alright, this is an example of the pump on Heath's truck. This is a Bosch VE style rotary injection pump. We're not providing a pump at this point for Heath's truck, but we want to talk about what can be done and a few characteristics of this pump. This pump got a high idle governed speed of 2650 RPM, so that's as fast as the engine will turn. You get going that fast and this thing will start shutting off fuel. Maximum delivery at torque backup happens at about 2100 RPMs, and this pump at full load is only capable of delivering, or is only calibrated in the factory setting to deliver about 90 cc's of fuel. Put that in perspective, when we're building a street style P pump for the next generation of pickups, we're often calibrating to 400, 500 cc's of fuel delivery. When we build a 13mm pulling pump from the P pump series, we might be calibrating to 1000 cc's of fuel delivery. This is the limitation of this combination. 90 cc's of fuel just isn't enough to get much done. We're going to start these modifications retaining his original injection pump. Seems to be in fine condition, seems to start and run okay. Out of the gate, what we'll probably recommend, this is fuel delivery screw, so this is calibration for overall fuel delivery. Again, the most this thing's going to be factory calibrated for is 90 cc's. You can back this lock nut off, run this adjustment screw in. In is more in this context, and we're talking a pretty minor adjustment here. Crudely speaking, one turn might get you 10%. You can safely go 2 turns. You might be able to get to 3 before you start to run into the governor fulcrum arm, but I would not go any further than 3 turns on the truck. I'd probably go to 2 and see what happens and how we like it. Okay, so this is what we've got. We're after safe, reliable, working class performance upgrades, and we're after a cost-effective solution in this scenario. Turbocharger assembled from remanufactured components. We'll have absolutely no issues with this. This will last a lifetime in this application. Brand new set of Bosch fuel injectors. And again, we're not providing a pump, but a little tweak on the fuel screw, and this thing's going to wake up and come right to life. Thanks for watching. Thanks to Heath for allowing us the opportunity to work on his truck and his components. Thanks to any viewers from Red Poppy Ranch that came over to our channel to watch the process of producing these components. If any of you need help with any of your diesel applications, please don't hesitate to reach out to us. We like to say we cover lawnmower to locomotive and everything in between. If you're in the market for any pumps, turbos, injectors, we can help you out with that, as well as a variety of other diesel components. If you need to get a hold of us, you can call us at 800-637-2658. That phone number rings our locations in Illinois, Indiana, and Iowa, where we have a team of customer service folks devoted to providing quality service and taking care of your needs. You can email us at parts@areadiesel.com. You can log on to our website at areadieselservice.com, and you can chat with us instantly through the button in the bottom right hand corner of your screen, where you're going to get immediate access to those same customer service oriented folks. So if you do need something and reach out to us and learn of us through this joint effort with Red Poppy Ranch, let us know that. We'll cover the shipping, whether it be something you're sending in for service work or something you're ordering for us to send out to you. And we'll also throw in a little freebie, whatever we've got at the time. Might be an insulated mug, a hat, a shirt, but we'll get you hooked up with some swag there as well. So if you enjoyed this process and this content, please give us a like or subscribe to our channel. We're pretty new at the YouTube thing, so if you've got any comments or suggestions, we'd love to hear them. Please drop them in the comments section so we can try and make better content for you in the future. Don't forget to go over to Heath's channel and watch the installation as he goes through modifying the truck, installing the turbo, installing the injectors, modifying the pump, and bringing this old beast back to life. So that's it. Thanks for watching.